Hey folks, welcome to this episode on predicting single displacement reaction. So when we're looking at predicting products, what we want to first figure out is what is the type of reaction. Like we saw before when we're looking at synthesis, combustion, and decomposition, if you know the type of reaction, you can figure out what kind of products you can get. Rearrange the chemical names or the symbols, if you're talking about a skeleton equation, to match what that general formula is showing. Determine the correct formulas, usually through the cross-down method if it's an ionic compound. If it's covalent, you'll just have to remember some of the main compounds that are created. And finally, balance the skeleton equation. Now, when it comes to writing the formulas, make sure that you are remembering if you have a diatomic molecule. So remember, anything that has as part of Hofbrinkel will be considered a diatomic molecule when by themselves, not when it's in a compound. Remember, when it's in a compound, you have to figure out what the charges are. So for example, when we have I by itself, it will be I2, but if it's HI, it will not be HI2, it will actually just be HI, because the charge for hydrogen is 1, the charge for iodine is -1, and we cross, we get HI. Never change those subscripts once you've created them. Okay? That changes the type of compound that you have. So one thing that you really have to remember is that the subscripts are not automatically carried over from one side to the other. Every time you create a formula, use this cross-down method to figure out what the correct formula is. All right, so when it comes to single displacement reactions, we have to look at our activity series to see if that reaction will happen. The first thing you need to do is identify your reaction. If you have an element plus a compound, you're dealing with a single displacement reaction. So here we have a single element. Metals are always found by themselves, and here we have a compound, HCl. The first thing we need to do after that is figure out, is this lone element a metal? Will it form a cation, or is it a non-metal? Will it form an anion? If it's a metal forming a cation, it will replace or try to displace the other cation in the compound. Okay, so zinc will not try to displace the chlorine. It will try to displace the hydrogen over here because they're both cations. Now, in this case, what we have to look is we have to refer back to our activity series and see if this is going to happen. Remember that for zinc to displace this cation, it has to be higher on the activity series than the ion it's trying to displace. So when we look at it, we can see that we have zinc over here, and it's trying to displace hydrogen, which is over here. So zinc can actually force its electrons onto hydrogen, and so this reaction will happen. Now, if we know that it's going to be a single displacement reaction, remember the general formula is A plus BC, and A and B are going to switch because in this case it's a metal, so it's going to be B plus AC. So all I'm going to do is I'm going to take my zinc and put it beside my chlorine. So there's my zinc and my chlorine. So I just put zinc, chlorine, and hydrogen. I just rearrange the elements just to see. Now I have to go back and try to figure out what the actual formula is. Now, this is an ionic compound, metal and non-metal, so I have to find my charges. Zinc we know is 2+, chlorine is 1-, so cross, and we get zinc chloride, which is ZnCl2. And H is a diatomic molecule, so it's going to be H2. Last thing we need to do is go ahead and balance, and there's our balanced equation. So let's do some examples here. If there is going to be a reaction, what we're going to try to do is figure out what the products are going to be. If there's no reaction, aka the metal that's by itself doesn't have enough activity to displace the cation or the anion later on in the reaction, then we're just going to write NR or no reaction. So this is a single displacement reaction. We have a single element plus a compound. So is barium a metal or a non-metal? This is a metal, so it's going to replace the other metal. It's going to be between barium and copper. So what we have to do is look for it on the activity series. Here is barium, and copper is all the way at the bottom over here. So does barium have enough activity to displace copper? Yes, it does. So it can move its electrons onto copper. So what that means is that based on my general formula, which is A plus BC, gives me AC plus B, my A is BA, my C is F, plus my CU. Okay, now I need to come up with the actual formula for BAF. Barium is 2+, fluorine is 1-, so cross, and I got BAF2, and copper is just by itself, so it's a metal, it's fine by itself. Now this is originated in aqueous solution, so this will most likely be aqueous as well, and this is going to be solid. Now we're going to figure out how to actually look at these and figure out how we can do the states once we get to our solubility table. But what we see here is that we have to balance. BA is 1, 1, there's 1, 1, and 2 Fs, so we are balanced. On the bottom here, you'll see that sometimes you'll get these metals with the Roman numeral. Now, by themselves, they have no charge, they're a neutral charge. What this Roman numeral refers to is that if it forms a compound with the nitrate, it's going to take on a 2+ charge. Okay? So by itself, it would still be just Pb solid, okay, plus Al bracket NO3 aqueous. Okay? If this was to form a compound, then it would be lead to nitrate. But we have to figure out if this is actually going to happen. Is lead have enough activity to displace aluminum? So let's find aluminum is right over here, and lead is all the way down here. Now, the single metal is by itself. It's trying to displace aluminum. It's not going to be able to do that. So what we have is we have no reaction. So go ahead, pause the video, see if you can do these by yourselves. We'll come back with the answers. So go ahead, pause the video now. Welcome back. So here are your answers. You can see that 2 out of the 3 reactions did not happen. For example, when we're looking at calcium and lithium, calcium is still a very reactive metal, but it's not as reactive as lithium over here. So it wasn't able to displace it. Same thing with nickel and sodium. Sodium is a very reactive metal. It's over in this red area. Remember that this red area reacts with cold water, acids, oxygen, while nickel is down over here. So it's a lot less reactive. It's not going to be able to displace sodium, and so you get no reaction. Now, sometimes when we're looking at these, sometimes they release hydrogen gas when it's reacting with water. So, will magnesium react with water? Well, on this little chart here, remember when we were talking about the activity series, we're saying that these are able to react with cold water, and these ones over here need steam or hot water. Now, specifically, when we look at it, aluminum, magnesium can deal with hot water, but the rest of them need steam. Okay? As you get into less reactive metals, they react less and less and less with water. So, for example, will magnesium react with water? Well, magnesium is right over here. So what it says, it's in that category of hot water and steam. So if we're talking about cold water, the answer is no. It's not going to have. It's going to be no reaction. Okay? But if we react with steam or hot water, hot H2O, yes, you will be able to displace hydrogen. So you'll have Mg plus H2O, and what you're going to do is you're going to produce this hydrogen gas. So you're going to get H2, and what's going to be left over is you're going to have a magnesium OH2. Okay, so you can go ahead and balance that. In this case, it's just that right there. Okay, so there's our balanced equation. So if we're talking about this water and this was gas, for example, it would still be liquid if it's hot water, but you just have to explain that it is hot water, not cold water. So go ahead, pause the video now, and try to figure out whether or not these metals will react with water in their forms. So if it's gas, it means vapor. If it's liquid, okay, if it's liquid, we're just going to assume that it's cold water. So welcome back. Here are your answers. So the only one that didn't work was the copper with the cold water. So copper is all the way down over here, a very unreactive metal. And you can see it's very, very far away from any kind of reaction with water, steam, or hot water. So what we can see, there's no reaction. The other ones did liberate or produce hydrogen gas. So here we had hydrogen gas and aluminum hydroxide. Sodium reacting with cold water. Sodium was over here, so it was able to react with this cold water to produce sodium hydroxide and H2 gas. Calcium was able to react with an acid. So here we have our acid over here. So anything in this little area reacts with acid. Here's calcium. It was able to produce H2 gas and calcium sulfate. That's just a single displacement reaction, displacing the hydrogen. And magnesium, was it able to displace the hydrogen from hydrogen chloride? Well, magnesium is right over here. Hydrogen is right over here. So yes, it will react to produce hydrogen gas and magnesium chloride. Now, in terms of our activity series, we also have one for halogens. And the more reactive ones, is as you go up the group. So fluorine is the most reactive, and that's because fluorine wants to gain electrons. Like metals want to lose electrons, non-metals want to gain electrons. So the more able that a halogen is to attract electrons and gain them, the more reactive they are. So that means that if you have a reaction between this fluorine and it's trying to displace bromine, fluorine will be able to rip out the electrons from bromine and gain them for themselves, so that reaction would happen. The opposite would not be true. So which of the following will react? So in this case, what we see here, we have fluorine and sodium and bromide, so sodium bromide. Will this reaction happen? So try to work with the activity series here. If fluorine has enough activity to replace or displace bromine, then the reaction will happen. If not, just write no reaction. So go ahead, pause the video, and we'll come back with the answers. All right, so welcome back. Here are the answers. So fluorine did have enough activity to replace the bromine in sodium bromide, and so you had a single displacement reaction. The fluorine replaced the bromine. And again, folks, remember that the formula is not created through, just because this is diatomic, it will not be F2. Okay, when fluorine bonds with sodium, Na and F, we have to look at the charges. So this is +1, this is minus, we cross, and we get NaF. So not NaF2, it doesn't transfer from one side to the other. Bromine by itself is diatomic, so it exists as Br2 and balanced. This reaction didn't work because here we're looking at iodine and we're trying to replace chlorine. So we're trying to do this action over here, and this is not going to work. Iodine is not more reactive than chlorine, and so chlorine is going to remain with its electrons. Iodine is not going to be able to rip the electrons away from chlorine, so this is going to be no reaction. And finally, we have this reaction that will exist between chlorine and bromine. So that's it, folks. Thanks very much for watching. See you next time.